Hey guys, Mr. Moore with the last video in our series on the calculus of the transcendental functions. The last one is over inverse trigonometric functions. While not prominent on the AP exam, it's still good to know how to do this. Here's a little bit of justification behind what we're doing. So, say we had this angle, let me just draw a bad triangle. So, we had this angle theta. And we know that the sine of theta equals x. All right, so if the sine of theta equals x, we know sine in general is opposite over hypotenuse. And if we were to derive both sides, we would get cosine theta d theta equals 1, or d theta dx, right? So if we were to solve for d theta over dx, we would get d theta over dx equals 1 over cosine, which is secant theta. So if we were going to do secant theta, secant is hypotenuse over adjacent. The problem is we don't know what this side is. But thankfully, we know the Pythagorean theorem, so it's going to be, we'll say like a squared plus x squared equals 1. And we can quickly justify that this is the square root of 1 minus x squared. Now, it's not any different than if we then said, well, if sine theta equals x, then we get sine inverse of x equals theta. Now we just determined, so if we did the derivative of this, we would on the right side we would get d theta over dx. Now it seems like we just figured out what d theta over dx is. It's secant theta. That's 1 over the square root of 1 minus x squared, which is what we have right here. Now, extrapolating this out to like a function, the thing I forgot to include in this table would be if we had the sine inverse of some function, that is equal to the derivative of that function over the square root of 1 minus that function squared. And that's going to be true for each one of these in the bottom. You replace x with f of x, and we're just going to end up with either f of x or negative f of x on the top for all of those. My apologies. The derivatives are pretty straightforward though. You will have a formula quiz over all of these and the formulas that we've done in the previous 3 videos. So study up. The first one is find each derivative. We have y equals sine inverse of 2x. So y prime is going to equal, so we need to multiply by the derivative of 2x, which is 2, and then divide it by the square root of 1 minus 2x squared. And that's pretty straightforward. We get 2 over the square root of 1 minus 4x squared. Example B, we're doing tangent inverse. So we would get y prime equals the derivative of 3x is 3 over 1 plus 3x squared. So 3 over 1 plus 9x squared, going by this rule. Letter C, we have f prime of x would equal, so for cosine inverse, it's like sine inverse except is negative. So we're going to have negative 1 times the derivative of 1 over x. So 1 over x is equal to x to the negative 1. And so if we calculate its derivative, that's times negative 1 times x to the negative 2. So this divided by the square root of 1 minus 1 over x squared, which equals Negative negative is going to be a positive, so we're going to have positive 1 over the x squared moves to the bottom, so x squared times the square root of 1 minus 1 over x squared. Oh, excuse me. So again, because I was writing out of frame, so the negative 1 comes from the formula. This negative 1 comes from multiplying this negative 1 to the front, and then we subtract 1 from the exponent. That gives us, after simplifying, positive 1, negative exponents move to the bottom, so x squared times the square root of 1 minus 1 over x squared. Letter D. So cosine of sine inverse 3x. There are two ways to do this. Let's look at both ways. Say we'll draw another triangle where we have this angle theta, so this side is 3x and that side is 1. If we wanted to know the cosine of theta, we need to determine this other side. We've already established that this would be the square root of 1 minus 9x squared. So cosine is adjacent over hypotenuse. So really the cosine of theta is equal to the square root of 1 minus 9x squared. We could take this derivative and end up with negative 18x divided by 2 times the square root of 1 minus 9x squared, but we're going to do it another way, which we'll see what happens. So when we take this derivative, we're going to get the derivative of cosine is negative sine, and you never change the input. So negative sine inverse 3x times, so then you multiply by the derivative of the angle, which that's going to be 3 over the square root of 1 minus 3x squared. Now, one thing we should know from functions analytic geometry is that these two guys get rid of each other. So sine and sine inverse get rid of each other and give you whatever follows it. So there's going to be negative 3x times 3. That's going to be negative 9x over the square root of 1 minus 9x squared. So remember over here we said we would get as a derivative negative 18x over 2 times the square root of 1 minus 9x squared, and then we can like cancel some stuff out. We get negative 9x over the square root of 1 minus 9x squared. It's exactly what we got. So there are two ways to do some of these. Letter E. Write the equation of the tangent line to f of x equals 1/2 tangent inverse x at the point where x equals negative square root 3. So as usual, the first thing we need to write the equation of a tangent line is the point, and subsequently we need the slope. F of negative square root 3 is, so where is tangent negative 1? Remember, inverse tangent is defined from negative pi over 2 to positive pi over 2. This is going to mean that we probably get negative pi over 3 as our answer. So we're going to have 1/2 tangent inverse of negative square root 3. That is indeed 1/2 times negative pi over 3, which is negative pi over 6. Second, we need the derivative evaluated at negative square root 3. So we would have 1/2 times 1 over, for tangent inverse it's pretty straightforward, just 1 plus x squared. And if we substitute in negative square root 3, that is 1/2 which equals 1/8. So the equation of the tangent line is y minus negative pi over 6 equals 1/8 times x minus negative square root 3. Fully simplified would be y plus pi over 6 equals 1/8 x plus the square root 3. Letter F. Identify any extrema, points of inflection, and asymptotes for cosine inverse x over 4. So for extrema we need the first derivative. For points of inflection, we need the second derivative. Asymptotes, like vertical asymptotes, that's going to probably be some stuff we can, this actually doesn't have any, we can take that out. So when we're doing, to find the extreme, add that, let's take asymptotes totally out. So to find any extrema, we need the first derivative. So y prime is, so the derivative of x over 4 is 1/4. But remember, cosine has that -1 on the top. So -1 times a 4th over the square root of 1 minus x over 4 squared. Now if we simplify this, that is -1 over 4 times the square root of 1 minus x squared over 16. You know what? Let's simplify some more because it might be necessary to find the second derivative. We're going to have 4 times the square root of, if we get a common denominator in the bottom, that's going to be 16 minus x squared over 16. So 16 minus x squared over 16. And then we could factor out inside this, that's like having 1 over 16 times 16 minus x squared. So that's, we could take out the square root of 1/16, which is 1/4, and a 4th times 4 is 1. So we end up with -1 over the square root of 16 minus x squared. Great. So to find the extrema, we need to find the critical values. Critical values occur where the derivative is either 0 or undefined. -1 never equals 0, but to find where it's undefined, we set 16 minus x squared equal to 0. So we get 16 equals x squared. So plus and minus 4 equals x. So in our number line, we have -4, we have +4. If x is less than -4, this is undefined. If x is greater than +4, this is also undefined. So we only have, this is only, the derivative is only usable between -4 and 4, which means that we do not have any extrema. And we can find out if this is increasing or decreasing by substituting in some value between -4 and 4, like 0. And since the square root has to be defined for positive numbers, we should get a positive. If we take the second derivative to find points of inflection, this is the same as having negative, so we can rewrite the derivative as y prime equals -1 times 16 minus x squared to the -1/2, so that the second derivative is +1/2 times 16 minus x squared to the -3/2 times 2x because of the chain rule. So simplifying, we get x over 16 minus x squared to the 3/2. So we picked up an additional hypercritical value of 0. We already know that for the bottom is -4 and +4. So we have -4, 0, and +4. Between -4 and 0, we should end up with a positive. Square root is going to be positive. Cube is going to be positive. On the top, you get a negative, so that would be negative. For 0, between 0 and 4, let's say we substitute in 1, that would be positive, that would be positive, so we end up with a positive. So we have a point of inflection at x equals 0. You know what? Point of inflection at x equals 0. To find the y value that corresponds to that, we go back to the original function, and we're looking for then y of 0 equals cosine inverse of 0 over 4, which, where is cosine equal to 0, that angle is pi over 2. So the point of inflection is at 0, pi over 2. Now again, we can't go beneath -4 or exceed +4 because it would have us taking square roots of negatives. So we just can't. So that concludes this video over inverse trigonometric functions and their derivatives. We'll do some recs in class. Thank you guys for watching.